Hi everyone, for this session we are going to continue the discussion of week 6 to 7 topics. So for now, we will discuss the mobility, the distribution, and the fate of those toxins we introduced in our previous session. So the example of those toxins, we have carcinogens, mutagens, teratogens, allergens, ESD, and many more. Now, there are several origins of poisonous and dangerous chemicals in the environment and various factors related to each compound itself. These factors for this environmental toxicity could be according to the toxic agent itself, according to the exposure of both biotic and abiotic community to the toxic agent, and related to the organism which is being affected or which is being exposed to the toxic agent. Now, the sources are the toxics. The sources are toxics, and those are those chemicals in the environment that is related to the release of the chemical itself. And the target of this chemical is both biotic and abiotic. So biotic, these are the living entities, and abiotic, these are the non-living entities. The environment is an example of abiotic community. The dose, which refers to the amount, the route of the entry, where it is being introduced, the portal of entry of those toxins in our body. It could be in the mouth from the food that we ate. It could be in the hands where we are touching those toxins and then introduce it into our body. It could be in the mouth again. We could have the nose. We inhale them. It could be in the eyes, no, and many more. The timing of the exposure, the sensitivity of the organisms all play in the essential functions in determining toxicity. Now let's start with the factors related to the toxic agent. Toxic agent, these are now the toxins that we're referring to that is harmful for both biotic and abiotic communities. So number one is the chemical composition and reactivity. This is now where biochemistry is related to environmental science. So since we are dealing with environmental science, in environmental science we have toxicity, the study of the toxins in the environment. And toxins, we need to know if it is reactive or not by knowing their chemical composition, and basically this is biochemistry about their chemical composition. The second one, we have the physical characteristics of solubility of the physical characteristics of the toxic agent. So such example of this physical characteristic is solubility. Now solubility, this is the ability of this toxic agent to be dissolved either in either in oil or in water. State if it is solid, gas, or liquid. Number 3, we have the presence of impurities or contaminants. Now, there are some toxic agents that are contaminated, and if other toxic agents once contaminated, it could amplify their effects, and as a consequence, there is a severity of what could be, the damage could be severe, unlike those toxic agent which is pure. Number 4, stability and storage characteristics of the toxic agent. So there are, but we need to consider the storage characteristics of these toxic agents, because there are others that when they are stored in specific room temperature, specific environment, and it's good for them, their effects are intact. However, if it is not stored in a acquired temperature or acquired environment for this toxic agent, so therefore it could either amplify the effect, or there is no effect at all to that the one that is being exposed to this toxin, either biotic or abiotic community. Number 5, availability of the vehicle, such as solvent to carry the agent. So in this case, we could also consider the container as one of the vehicle for the storage of the solvent. Number 6, movement of the agent through contaminant through environment and into the cell. So this is now the route of entry that what we are referring to. So how does this toxic agent are introduced into the environment and into the cells, specifically for the living entities kasi meron na ditong cells. Next, we have the factors related to the exposure. So eto na, we are referring to those organisms. Actually, it's not only organisms, as well as for the non-living things when they are being exposed to the toxic agent or the toxins, the poisons. Number one, we have the dose. So concentration and the volume of the exposure. The higher, most probably, the higher the concentration of those toxic agent, the higher the effect. The lower the concentration, the lower the effect. Number two, we have the route, the rate, and the site of exposure. So route, saan papunta? This is the route of the entry. Rate, gaano kabilis, gaano kahina. And site of exposure, saan banda? Let's say, for instance, for an organism, either for human being, in the mouth, in the nose, in the eyes, in the hands, whatever. Number three, we have the duration and frequency of the exposure. So duration, how long, gaano katagal ito. Frequency, is it, how frequent is it? Is it every day, every minute, every hour, etc. Number four, the time of exposure. Anong oras po ito? Is it day? Is it night? Season, either rainy days, winter, whatever. And then lastly, we have the factors related to organisms. Now, this is now the organisms, the living entities that being exposed to the toxic agent, and we need to consider them. Number one, we have the resistance to uptake, storage, or cell permeability of the agent. Now, there are some cases, there are some organisms which is resistant to that specific molecule, materials, or toxin, for example. So they could resist simply because it could either be impermeable to their cell. The agent, the toxic agent, is impermeable, so it cannot penetrate, it cannot go deeper to the body simply because there is no portal of entry in the cell kasi impermeable man siya, so hindi siya makapasok. The second one, we have ability to metabolize, inactivate, sequester, or eliminate the agent. So how can they metabolize? Could they metabolize those toxic agent, those foreign materials introduced to them? Could they inactivate it? How did they sequester? And are they capable of eliminating the agent? Number three, we have tendency to activate or alter non-toxic substances, so they become toxic. Now, there are some organisms wherein once they will be able to, or they are exposed, they can sequester toxins. No, it's not toxin, but a certain molecule. However, once they sequester that, they could activate it, and they can transform it from non-toxic to toxic particles. Number four, concurrent infections or physical or chemical stress. Now, concurrent meaning to say if meron ba. So let's say they are exposed to this toxic agent, and at the same time they are physically stressed, they are chemically stressed kasi meron na naka-introduce na sa kanila, or meron na silang infections, so it could amplify the effect, or there might be it could hinder their there might be a health crisis later on. Number five, species and genetic characteristics of the organism. So let's say we have, if they are mutant, if they are resistant, and the same with this one, resistance. So genetic composition of that organism. So other are, because of their genetic characteristics, they are susceptible to the toxins. However, others are not susceptible kasi their genetic composition is they are not very, anong tawag niyan? Hindi sila agad-agad maano ng toxin. Okay, so what are the example? So let's say you are immunocompromised already. Some are hereditary, so namana mo siya. Let's say you have an asthma, so and once you are introduced to this toxin or the toxic agent, let's say we have a pollen or an insect, so basically, of course, compared to those healthy individual na walang asthma. So, madali lang for those immunocompromised individual na may allergic reaction. Number 6, nutritional status of the subject. So, are they healthy? Of course, are they not? And number 7, we have what are the age, the sex, the body weight, and immunological status and maturity. So, may mga cases that this specific toxin, once introduced, they are the male population are susceptible, while when female population are not, or vice versa. So meron ding age, ito siya, this is more common in children other than the younger ones, the children rather than the older ones. And we have immunological status, yung mga immunocompromised individual. So in this figure, it shows the routes of the exposure to toxic and hazardous environmental factors. So we have here the portal of entry, saan papunta. So we have water, so of course, no, sa bibig ito, food, ano pa, for smoking, so sa lungs siya, but portal of entry, yeah, it would be the mouth, if you are second or third sa ilong, nose. We have trauma, ito siya, so in your ligaments, upper lower limb. Saan pa? Food poisoning sa bibig, air pollution, so breathing, so same pa rin sa lungs, but the portal of entry is in the mouth. So yung route niya is sa lungs. Okay, so next we have bioaccumulation and biomagnification. Now, bioaccumulation, by definition, this is how the cell performs selective absorption and the storage variation of the molecules. Meaning to say, this is how the cell uptake or sequester the chemicals in the environment. The chemicals itself, the toxin, could penetrate in the cell. This is bioaccumulation. It allows to accumulate nutrients and essential minerals, but at the same manner, at the same time, they may also absorb and store harmful substances through the same time mechanisms. Toxins or poisons are instead dilute in the environment that can reach dangerous levels inside the cells and tissues through the process of bioaccumulation. Now, what's the difference between the bioaccumulation and biomagnification? So in this case, it is being defined here based in this figure that bioaccumulation and biomagnification increase the concentrations of the toxins. Bioaccumulation, this is in a cellular level. This is how a species, an organism, could accumulate a toxin or a poison in their in their cell. Biomagnification, this is how an organism consume another organism and their toxicity will increase in a higher level. No? So remember the food chain and the food web. So let's say for instance we have here a fish. The fish could bioaccumulate a mercury, perhaps. That's an example. So they could accumulate that one. Now the thing is, of course, the fish will be eaten by an animals or a fish, the fish will be eaten by a man, or let's say we have the fish could be eaten by these specific animals and these animals can be eaten by these animals. So as the food web will go higher, so does the accumulation of the toxins. Lower here in the species, the one that accumulate the toxin, and higher in this one. Okay, so that's biomagnification. Biomagnification occurs when the toxic burden of a large number of organisms at a lower trophic level is accumulated and concentrated by a predator in a higher trophic level. So napataas siya, nagkadaghan ang iyahang accumulations. In this case, this is the accumulation of methyl mercury in the ecosystem. Then the next one we have here, the persistent. These are the example of persistent organic pollutants. Now the thing is, there are other substances which is persistent to degradation and they could last for a longer years in the ecosystem or the environment. I know you are familiar with the plastics, the tin cans. So if you threw them in your backyard perhaps, then after how many years, let's say after 5 years, so makikita nyo pa, meron pa siyang mga remnants kasi hindi sila, they are not biodegradable. No? Biodegradable, those are the materials or substances that could easily be degraded in a short period of time. They will be part in the ecosystem. So these are the examples of persistent organic pollutants, or also known as POPs, and it is often accumulate in the food web and reach toxic levels in along living predators such as human, sharks, and bears. Now in this case, this is an example of bio magnification, no? So for lower animals, it is not, somehow we could say that they are not dangerous. It's okay for them, they could tolerate that. However, this toxin, they could be dangerous for living predators, and once they reach it, they reach with this living predators such as human, sharks, and bears, they are already toxic. Okay, so what are the examples? So here we have PBDE, or polybrominated diphenyl ethers. They are used as flame retardants in textiles, foam in upholstery, and plastics in appliances and computers. So here, I think you're familiar with upholstery. No? So napapalagay ka ng mga kutsyon sa mga bangko or sofa, couch, computers, ayan siya. So low exposures in the womb or after birth can rapidly harm children's reproductive and nervous system. This is the effect of the PBD. So ayan siya. So it's not good for pregnant women and for children if you are exposed with these materials, and these materials are found, or this chemical are found in these materials. Second one, we have PFOs and PFOA. So if you are if you are a kind of a kitchen woman or a man, no? So palagian nasa kitchen, so you're familiar with stick and non-stick. So meron silang perfluorooctane sulfonate or PFO and perfluorooctanoic acid or PFOA. So this chemical is used to make non-stick, waterproof, and stain resistant products. So ito po, no, so yung mga, what do you call this one, yung mga kalaha, so ayan siya, mga non-stick. So typically it's good for cooking, yung mga non-stain products, hindi agad-agad malalagyan ng stain. So they are being their materials, they are mixed with these chemicals. So it has been shown to cause liver damage as well as various cancers and reproductive and developmental problem in rats. This is according to research. Exposure may be essentially dangerous to women and girls, 100 times more sensitive than men to this chemical. So ito na yung sinabi ng factors, environmental factors, and factors related to the organisms. The exposure according to sex. So it is 100 times more sensitive than men for women to be exposed in PFOs and PFOA. And then we have the phthalates. So phthalates, they are found in cosmetics. You are familiar with cosmetics, yung mga pampaganda, deodorants, and plastics such as PVCs. In fact, we could found these materials in our home, no? So most common po ito. They are used for food packaging. Ayan siya, pag may party kayo, tapos food package na lang, children's toys, and many medical devices. Now, if you are exposed, what are the risks of the phthalates? So, some can cause kidney and liver damage and possibly some cancers. That is why it is advisable that plastics are not is only for one-time use. No, so yung mga lalagyan ng mga tubig if you're using that for a longer period of time. So ito po, so these are the effects and it could act as endocrine hormone disruptors, yung ESD natin, have been linked to reproductive abnormalities and decrease in fertility. So in the long run, you will be infertile, for either for both men and women. And then we have the perchlorate. So this is a waterborne contaminant left over from a propellants or a rocket fuels. So this is very uncommon, but still they exist in the environment. So it can interfere with the iodine uptake in the thyroid gland, and they could disrupt adult metabolism, kasi of course we have here iodine, and the children development. Now, in terms of the interactions, chemicals or toxins could interact, and it could increase the toxicity level. There are two types of reactions of chemicals. One is antagonistic, and the other one is synergism. Where is it? Ayan, antagonistic, and the other one we have synergism or synergic reactions. Now, how will you differentiate the two? Antagonistic reactions, by definition, these are some materials interfere with the effects or stimulate the breakdown of other chemicals. So for example, here we have vitamin E and A can reduce the response of carcinogens. Now, if you are exposed to carcinogens and then you are taking not vitamin E, then that's good. However, if you are taking both vitamin E and vitamin A, so it could amplify the effect to reduce the good response in a high it could response positively to carcinogens or other toxins rather than individual dosage of both vitamins. So ayan siya. So mas maigi na dalawa sila kasi mas ma-reduce na agad-agad yung carcinogens na na-introduce sa ating katawan. On the other hand, there are others which others are additive when they occur together in the exposures. So let's say for instance, we have the rats exposed to both the lead and arsenic, shows twice the toxicity of only one of these elements. So additive po, meaning to say mag-add-ons lang siya. Now, in this experiment, na-expose yung rats sa lead at saka sa arsenic. However, the result shows that the toxicity is twice only one of these elements. The rats exposed to lead and arsenic, so kung ano yung toxin or ano yung the toxicity or the effect of these elements to the rats is dalawahan siya, na shows the twice of the toxicity. So kung ano yung effect ng dalawang lead, or either effect ng dalawang lead or effect ng dalawang arsenic, in comparison to the rats which is being exposed to only one, either the lead or the arsenic. So mas grabe yung effect if the rat is being exposed to both of them kasi magiging additive siya. Iya siyang i-amplify ang effect. And here in this example, so dapat dalawa para faster yung effect. Mas ma-amplify siya kaysa individual uptake. The second one, we have synergism or synergic reaction. So by definition, this is an interaction in which one substance exacerbates the effects of the other. So same pa rin. So ihagihapon siyang i-amplify ng sobrang-sobra. So in this example, we have here occupational asbestos exposure or smoking increases lung cancer rates 20 times. What does it mean? So yung mga workers who are exposed in asbestos, or please note of this word, nag-smoke sila, their lung cancer rate is 20 times. But asbestos workers who smoke has 400 times increase in the cancer. So mas grabe yung exacerbates man. So pinalala niya talaga, exacerbates the effects of the other. So if you are working and then you are exposed in the asbestos, and at the same manner, you are a smoker, so therefore, so from 20 times for individual exposure, either asbestos, 20 times, so you're a smoker 20 times. Pero pag sinabay mo sila, you are exposed in the asbestos, at the same time you're a smoker, then you have the probability of 40 times increase in cancer rates. So, ayan siya. So, you see the gap? It's very, So, grabe yung gap niya. Huge amount of numbers. So, from 20 to 400. So, what are the occupations in which who are those individuals or professionals who are exposed to asbestos? So we have military veterans, construction and demolition, electricians, painters, railroad workers, iron workers and welders, insulation workers, pipe fitters, shipbuilders, miners, and any other trades. So, ayan siya ha. And then, if you know it already na may kakilala kayo, tapos they are smoker, then tell them that they have the probability of 40 times increase in the cancer rates. Now, what to do if you are working? So, you need to follow a safety protocol. So, ayan siya, safety first. So, you need to wear your PPE. At the same time, you need to wash your hands all the time. Another one, we have measuring toxicity. Now, measuring toxicity by definition, this is a convenient way to describe toxicity of a chemical to determine the dose to which a 50% of the test population is sensitive, or what we known as the LD50. Now, what is an LD50? LD50, this is an amount of material given at all once which caused the death of 50%. This is 1/2 out of the total for the number population. So let's say you have 100 sample population. That's your sample population. You're sampling your sampling population. Now 50%, so 50% of that rat population died. So ayan siya yung pag-measure, yung LD50 of the group test of the animals. LD50 is one way to measure the short-term poisoning, acute potential toxicity of the material. Now, to further understand the concept, so we have here yung LD50. This is the best way in order for us to measure the acute toxicity. Okay, now we have here in this diagram acute toxicity and chronic toxicity. Acute toxicity, by definition, this is a life-threatening one-time doses. And if you are going to compare this with the chronic toxicity, this is the exposure of an organism to that specific toxin within an hour or a day. So, madalian lang po siya. Kadyot lang siya, no? Dali ragyod kayo, an hour or a day. Whereas, for the chronic toxicity, it takes many months or years to become recognizable para ma-recognize siya. So, it is that these are the most common acceptable daily intakes of this minimal concern. However, in the long run, after how many years, kasi nag-accumulate naman siya, then you can be, as a result, as a consequences, there could be a health crisis later on. So, mayroon ng mga clinical diagnosis. So, may mga hypertension, diabetes, and so on. Ito naman, madalian, no? So, pabigla-bigla, meaning to say, you introduce this toxin with a duration of hour or a day, tapos bigger amount in comparison to the chronic. So, let's say here, these are the substance. So, saan sila makikita? Tapos, yung lethal dose natin. Again, yung lethal dose natin is, it could cause the death of 50% of the test population. No? So, it's very effective, of course, kasi imagine you could, let's say you have 100 sampling population of rats, and then you introduce the substances. So, if 50%, ayan, so, ito yung dose niya. These are the lethal dose that could kill 50% of the population, sample population that you have in your lab experiment. Now, we have here the water. So, saan makikita? Of course, sa tubig, sucrose, down to aluminum hydroxide. Now, the thing is, meron din tayong category dito. So, practically non-toxic, slightly toxic, moderately toxic, and highly toxic. So, of course, hindi tayo mag-focus sa mga non-toxic. Dito tayo sa highly toxic. So, highly toxic, what are the example? Yung mga hydrogen cyanide. Ayan siya. So, saan makikita? We have the fruit pits and bitter cassava. So, familiar with the cassava. So, meron siyang hydrogen cyanide. Makahilo daw na siya. So, you need to cook them well. So, lethal dose, LD50. This is the milligram. 40 milligram per kilogram. Okay, so we have 4. So, if you could take 4 milligram per kilogram. So, LD50, 4 milligram per kilogram. So, it's very lethal. It's toxic. Aflatoxin, so saan makikita? Sa fungus, yung sa mga moldy foods. Ayan, sila yung nag-produce nitong aflatoxin. So, 5. Mycotoxin sa mga pathogen, sa mga grains, 5 pa rin. Nicotine, 10. So, ito po sa mga tobacco, mga smokers, nasa smoke ito. Saan pa? We also have vitamin D3 sa mga supplements sa 37. Moderately toxic, we have copper sulfate. Sa saan makikita? We have fungicide. So, 300. Chlorovirus, pesticide pa rin ito. 230. Caffeine, lead sa mga batteries. 155. DDT, pesticides pa rin. Insecticides, so 160. So, once you uptake this amount, so of course this is lethal, and in some cases it could cause to death. Chronic toxicity, so ito siya, the same with here, however meron siyang mga limit per day. So water, we have 5,000, 50,000. These are considered as non-toxin. So dito tayo, no? So mycotoxin, we have here 0.002. So, fusarium, this is a form of what? Fungus. Most common makikita ito sa cassava, no? Sa mga saging banana plantation. Moldy grain, so they are responsible of releasing mycotoxin. So, if you are exposed, meron ka lang limit dito na ganito, 0.002. In this case, eto siya. Imagine ha, this is the daily dose na limit mo. Tapos, if you are exposed to mycotoxin for acute toxicity, ayan siya sa 5. So, this is considered as toxic already pag umabot ka nito. But, of course, even if konti lang siya yung uptake mo for this one, for mycotoxin, but in the long run, let's say na-expose ka ng mycotoxin for 10 years, so, technically, of course, ayan siya, you will experience health crisis sooner or later.